Hello and welcome to Marvin's Tutoring. I'm Marvin Lee, your online physics and chemistry tutor. Today we'll be going through my chemistry worksheet 1, which will be available on my website, which I will link in the description down below. So make sure to check it out when you get some time. So we're going to go through some questions today, specifically in chemistry. And please note that this question is not the only one. There's still question 2, which will split in on other pages. Okay. Now, if we look at question 1, let's start. If we look at question 1 is a very difficult question, not because of the way you have to answer it, but the way the questions are being asked. Okay. So you need to know certain things in order to be able to answer the questions. And if you don't know certain things, then you will lose some marks. Now, question 1 says, in a controlled experiment, so that's your statement, please, going off topic, please always read the statement or the diagram, whatever they give you, statement, diagram, or picture, usually. Please look at the details they give you. Please make sure that you go through them thoroughly and you understand each and every single little thing, because there are details in there that you most definitely will use. Okay, I'm going to show you what I mean. So firstly, I want us to look at some things that I want going to be important in the statement. So while we're reading the statement, we're going to be highlighting as well. Okay. Let me just scroll. Okay. And it says, in a controlled experiment, let me just get my highlighter. In a controlled experiment, 13 grams of potassium is added to ice. Okay, it's added to ice. It's a controlled experiment. That might also be important, we don't know. Use the information provided in the statement to answer the questions below. Then 1.1 says, in a chemical reaction, potassium reacts. Okay, in a chemical reaction, that is important. Potassium reacts with ice to produce that tells you that your products are being formed. So your products are being formed. The word produce tells you that your products are being formed. So that means whatever is here is what's gonna come after the arrow. Okay. Produce potassium hydroxide and hydrogen gas. Okay, now let's read the question. It says 1.1, write the word equation above as unbalanced. When they tell you unbalanced, you cannot write a balanced equation because you will lose all 2 marks. That's not what the instructions taught you. Therefore, you will be penalized. Okay, and I want us to do this one together. So if you can, pause the video and try and see how you do it. I'm going to give you, just pause and try and see if you can do it. Otherwise, I'm just going to continue. So if we look, it says potassium is our first one. So we're going to put it first. I'm just going to make this smaller. Move it to the side. There we go. It says in a chemical reaction, okay? Now, potassium, you need to know in order to answer such questions, to balance and to get the molar mass, to basically everything chemistry, you need to know your periodic table. That's why most teachers say you need to know the first 20 elements of your periodic table. Sometimes they might ask for elements that are after, but that happens rarely. So that's why they always tell you at least know the first 20. Okay, by name. Okay. So we're gonna start. Potassium is a K on the periodic table, so we're gonna write it like that. Now, because potassium is a metal, we don't need to add anything to it. It can stand alone. Okay. And then it says react with ice. Ice, this is just to trick you. Ice is a solid form of water. It will not, however, change the chemical equation of water, how water is. Okay, so ice will be H2O. Okay, then they tell you your products form. So when they tell you your products form, that means you draw your arrow. Okay, and your products are potassium hydroxide. Now we know hydroxide is a OH from our cations and anions. If you don't know that, please go study it. OH minus, but we're not going to put the minus. Okay. Then we're going to look, it says hydrogen gas. Now, I want you to be very careful here, because hydrogen gas is a non-metal. Hydrogen gas is a non-metal. So when you write it, you're going to write an H still, but it cannot stand alone in the equation. It needs like a buddy or a friend. Therefore, we need two of them to be able to fill in the orbital. And that's it. You are done with question 1.1.1. See, the way they're asking the question might be difficult, like they're adding words like ice to throw you off or whatever. But if you know this, it will be very easy to answer. Now, I'm just going to take something off so I have some space. Then we're going to look at our second question. Our second question tells us balance the chemical equation above. Now, when they ask you to, I didn't make space, but when they ask you to balance a chemical equation, I'm just going to do this with the same thing because they're asking us for the same equation to balance it. So I'm just going to use this one. When they're asking you to balance something, please make sure that there are space to put numbers and whatever in front of your. What I mean by that is please make sure there's enough space between your substances or your chemical formulas. So if we look at that, make sure you have numbers in front, not numbers, sorry, space. And then you can either do a solid line or you can do like a line that breaks. I prefer line that breaks because that's basically how I've been doing it. Now on each side, because we're balancing, we're going to look at how much of what we have. So if we look here, we have a K, we have a H, and we have O. The side must be the same, otherwise it's not balanceable, basically. So yeah, we have the same things. Now, if we look properly, here on this side, we have 1K, but we also have 1K on this side. Here on this side, we have two H's. And on this side, we have 3 of them because it's this one plus these 2. So it's 2 of them. And then we have 1 O. No. Mistake, 3. Sorry, 3. My math ain't mathing. And then the O's are 1. The O's are 1. Okay. Now that we have that, we know that some things are unbalanced in our equation. So we're going to look at the one that has that doesn't have much, and we're going to add to it. Now, usually we start with a 2. If a 2 doesn't work, we go through a 3, and you just keep increasing the number. If it doesn't balance, eventually it will balance. I don't think it will go above 4. Okay. So let's start. if we add, because we have 2 hydrogens here, but we have 3 that side, so we're going to definitely add something here. So let's add it to here. Sorry. Let's add it to here. Let me do that properly. Let's add it to here. But now it means, okay, we have 4 hydrogens and 2, because the 2 is for both of them. The 2 is for both of them. And 2 oxygens. Okay. Now, if we look on this side, because we have 2 oxygens on this side, we need to add another 2 here to make the oxygens 2. Now our oxygens are balanced. Our H's are also balanced, because now it will be 2 times 1 and it will be 4. But our K's will be 2. So what we need to do is balance this side and put a 2 there. If we put a 2 there, then this will be balanced. Basically, you have balanced your whole equation. Therefore, your balanced equation would be 2K plus 2H2O forms 2KOH plus H2. Hopefully that's a bit understandable of what I did here. The trick with this question was, if you didn't write it down as the equation correctly in the previous statement, so if you, for 1.1.1, if you didn't write it down correctly, then you would have lost that mark automatically, because your thingy would have been wrong. Your equation would have been wrong. Therefore, you couldn't have balanced it properly. Then let's look at 1.2. 1.2 says calculate the mole of potassium in this equation. Now, we know for moles there are two main formulas that we use, and I'm going to show you both formulas. The first the first formula we have is N is equals to M, small m, over big M. Or the other one we have is N is equals to V over Vm, molar volume. Okay, now because we're not working with volume, we don't have a volume, we don't know if it's at STD or whatever, we are going to cancel out this equation. So we're not going to use this one at all for this instance. Instead, we're going to use this one. Now, because we're going to use this one, let's look at what they give us in our basically question and statements. They say potassium. Now, if you look properly, potassium on the periodic table has a molar mass of potassium. The molar mass of potassium is 39 grams per mole. 39 grams per mole. Okay. Then they also gave us the massa. That's why I told you need to read your statement, because if you didn't read your statement, you wouldn't have seen this. It says in a controlled experiment, 13 grams of potassium is added to ice. So 13 grams of potassium is added to ice. Therefore, they gave you the massa, and your massa was 13 grams. Because it's already in grams, we don't need to convert anything, and we're looking for N. Now we're just going to substitute everything. We're just going to put everything in. So we're going to say, N, because we don't have it. Our massa is 13. And our molar mass is 39. Then, Then we're going to write down our final answer. And our final answer is, if you calculate it correctly, 0.33 mole. Usually in your test, they would say like round off to 2 decimals. So that's why I'm just putting this as my answer. And that is your final answer. So that's why you need to read your statement in order to be able to see this. Now, next, they're asking you about the reliability of how the scientists could basically make this 1.3. They're asking how the scientists could have made this experiment more reliable, or would ensure that this experiment is more reliable. And there are different answers to that, and I'm going to put them on the screen. But the main thing you need to know is that reliability and validity is not the same thing. So if you wrote something that would have basically answered the question, if you were saying how would you made it more valid, then your answer would have automatically been wrong. Validity and reliability are not the same. They are not the same. Okay, and those are the answers on the screen that you could have given. For question 2, if you look, they give us a very long statement and then a graph that looks like basically, you wouldn't know what to do. But let me break it up for you. So it says a learner investigates the physical properties of two mixtures, labeled substance 1 and substance 2. Pure water is assigned as substance 1, while salt water is assigned as substance 2. Equal samples of each substance are placed in separate containers and heated under identical conditions. The temperature of each substance is recorded at 5-minute intervals over a period of 40 minutes as they are heated from the same initial temperature until boiling occurs. The results are used to compare the boiling behavior and phase changes of the two substances. A boiling point graph for each substance is provided below to support analysis of the data. Okay, and then they give us, and very important, stof means substance. That's just the Afrikaans word. I forgot to translate it when I was doing the graph, and I couldn't change it. Okay. Then let's look at the questions. Now, this one I'm going to start it a bit different. We are going to look at questions. The first question says, define the term boiling point. Now, the correct definition, there are many definitions for boiling point, but the one I'm going to give you, please use the one that they gave you at school, because, I'm not marking your test. Your teacher is marking your test. So, the temperature at which the vapor pressure equal, this word is very important, equals atmospheric pressure. And that is basically your definition of a cooking point. Now, remember what I said? Many people use many different definitions. Use the one they taught you at school. Okay. Then we are going to look at our other question. And our other question says, refers to substance 2. So now you're not going to focus on stof 1. You're going to focus on stof 2, which is substance 2. And now it says name the solute. So name the solute. Ooh, okay. Name the solute. They want the solute And they also want the homogeneous mixture. Homogeneous mixture. Okay, I'm not going to write the full thing because I don't have much space. Now, the solute, you can either say it's a salt, because if you read properly, they said, they gave it to you. They said, we're looking at substance 2. While salt water is assigned as substance 2. So it means it's a solution of salt water. Now, we're looking at a homogeneous mixture here. And in that homogeneous mixture, the solute is your salt and the solvent is your water. Okay. And then the homogeneous mixture is the one that they gave you, basically. You can either say, okay, there are multiple answers. So you could have said salt or sodium chloride, the scientific name. Chloride. I'm just gonna squish it in here. Or, yeah, those are basically the two. Or, okay, for your homogeneous mixture, you can say there are 3 options. So there's salt solution. The other one is salt water. And the other one is sodium chloride solution. I'm not going to write that one out. So the other one is also sodium chloride solution. Okay, I think you basically get the idea of what they're asking you. Now this question, so far it's a decent question. So far it's a really great question. Now then they ask you to state one difference between a homogeneous and a heterogeneous mixture. I'm going to put the differences on the screen just so you can see them. You can pause and look at them for a moment if you need to. Then we are just going to go to 2.3. 2.3 says, okay, 2.3, the most important thing I want to highlight here is it says explain and the mark allocation. The mark allocation and the word explain tell you a lot. The word explain means that you have to do the following. Because it's 3 marks, you have to give a statement, which will give you your first mark, and a reason. Okay? But it's 3 marks. 3 marks. Therefore, you will have to give 3 reasons. So when it's an explain question, you have to you have to give a statement and a reason. But if it's 3 marks, or if it was 4 marks, you'd have given 3 reasons. If it was 2 marks, you would have only given 1 reason. Okay. Now, how are you going to answer this? Let's look. Firstly, you need to explain why the substance 1 boiling point is lower than that of substance 2. In order to do that, you need to know the difference between them. What is what? Which one is which? Basically. So, if we look, our statement is pure water, because they told you it's pure water. Substance 1 is pure water. Sorry about that. Let me just fix that. Pure water doesn't contain salt. Okay, it doesn't have salt. It does not contain salt. Now, your reason, you gave your statement. Remember, in your test, you're not going to answer it with the S or R. That is just for you to remember. Okay. Pure water doesn't contain salt. Why are we saying that? That's our statement. Now we need to further elaborate because we're not giving much detail here. The examiner wants to know why you're saying that. You need to explain. Then you're going to say the dissolved salt or salt particles increase the boiling point. The dissolved particles, salt particles will, let me just remove this, will increase the boiling point of substance two. Okay, then now you're going to talk about the energy needed or the heat or whatever you need to call it, basically. Okay, so now we are giving our third reason, and we're going to talk about the energy and heat. We know that there's more heat needed to break bonds if the bonds are a specific type of bonds. Okay, so we're going to say more heat, or you can say energy needed. I'm giving short answers, so you can give full answers. For water molecules in salt, or you can say substance 2. I'm gonna say S2. In substance 2 to escape into gas phase. And that's it. There are your 3 marks. Now it's a very long explanation for 3 marks, but the examiner does basically expect you to answer everything fully. Okay, then now we're going to be looking at number 2.4. Okay, now 2.4 is a bit of a difficult one because there are some tricks that they are trying to catch you with. And if you don't know this, you would fall for those tricks. Okay. They tell you in 2.4, let me just zoom in a bit. 2.4 says, an investigation was conducted under standard temperature and pressure, so STP conditions. A mass of 400 milligrams of sodium chloride was added to 250 cubic centimeter water before heating. Use the information provided to answer the questions that follow. Sorry. So now they want the number of moles of salt. Now, here's the thing. Like I told you in question 1, there are 2 types of formulas for basically moles. It's this one, big M and small m, or this, N is equals to V over Vm. Now, a lot of people would fall into the trick of using this formula, and I'll tell you why. Because they give you a volume and they tell you that it's an STP, then you would automatically assume that this value would be the molar mass of the molar volume of a gas. But at STD, STP, in Afrikaans it's STD and I'm used to Afrikaans, when you're using this value for Vm, it has to be for a gas. Now look what they're asking for. They're asking you for sodium chloride. Sodium chloride is a solid at STD. We know that. Sodium chloride is a solid at STD. Therefore, this 22,4 is not applicable. Therefore, you cannot use this formula. Okay. STP. I keep saying STD. Therefore, you're going to use the other formula. Okay. So that's basically how they would try to catch you. So now we're gonna they gave us everything that we need to answer this question. So we just need to look at what and how we can answer it. Let's look at what we have. We're looking for N, so we're gonna write N here, and we don't have N. We have small m because they told us it's 400 milligram. Now you need to convert the 400 milligram. In order to convert from milligram to grams, you need to divide by 1,000 and you will get 0.4 grams. Okay, then the molar mass, you know already how to calculate molar mass. So if you look on the periodic table and you add them together, it would be sodium is Na plus Cl2. Remember? Okay. NaCl2, and that would give you a total of 58.5 gram per mole. Now that you have all your values, now that you have your values, you can substitute in. N is equals to M. Your M is 0.4, we just calculated it, divided by your molar mass, which is 58.5. N is equals to a total of, okay, so it's gonna give you, it depends on your calculator, but my calculator is giving me 0.84 times 10 to the power of negative 3 mole. And that is your final answer. Then you can get your 3 marks. Now let's look at the last question. The thing is, if you got your answer wrong here, then they can do something called positive marking, which means for the next question you can get your mark if you use the same value even though it was wrong. So yeah, let's look. It depends on the type of question though. The concentration. Now we know concentration is C is equals to N over volume. The concentration of sodium chloride solution, they already gave us the volume. We have the moles, but our volume is in cubic centimeter. So now we need to divide by 100 to get it to cubic decimeter. And if you do that, you would get that your answer is 0.25 decimeter. Okay, cubic decimeter, basically. Okay, and that is your volume. Okay, now you have your volume, you have your moles. We said your moles in the previous question was 84 times 10 to the power of negative 3 over 0.24, and that is equals to concentration. Then you would get your answer as 0.03 moles per cubic decimeter. Okay, hopefully you guys understand all that. Now the reason why we some of you's answers might differ here a little bit, and it might be in or out of range depending on how what number you got for your moles. Okay, so the number of your moles might change this a bit, but that's totally fine. And this would be your final answer. Now remember, moles per cubic decimeter. Okay, and that is your final answer. And we have reached the end of today's video. If you want to see more videos, comment in the comment section what type of videos you'd like to see, and I would take some time and look at them for you. For now, enjoy the studying, enjoy the June holidays, and see you next time. Marvin out.